So, good morning, everyone. Well, late good morning, good lunchtime to everyone, I would say, Norwegian lunchtime. We have a tight schedule at Arctic Frontiers, so I just want to start on time and try to make sure that everyone can have a proper lunch afterwards. Welcome to the third block of this session on Arctic health to ecosystems. Very nice to see so many people here in the room. Been a very interesting day as well. Yesterday we had a lot of talks, very excellent science talks, talking about the pressures on the Arctic ecosystems, the different components being impacted, the risk associated with it. Ecosystems are large, many components, it's a very complex issue, but we touched upon a lot of those subjects yesterday, so that was great. We also saw some risk assessment frameworks appearing, even multiple stressors, which is the reality of our ecosystems these days. Today we're gonna shift gears a little bit because there's a lot of science, but of course the science and the knowledge has to go somewhere. So how do we go at it with that? So we are organizing a little panel debate of about half an hour at the end of the session here, of this block of presentations. And for that we have especially chosen also 4 speakers today who are touching upon different elements that will help us get that panel debate going. The panel debates is gonna especially focus on how to make the framework more actionable, especially in the topic of this conference, which is about action reaction. How do we move forward with the knowledge that we have? And so we've chosen to address the Central Arctic Ocean is of big interest. You've heard this many times, I think, the last years. So that's what we're gonna do this morning. So we have 4 speakers today. The first one traveled a very far distance, especially for us, from Korea, so Hyung Chul Sing. I'm very sorry for pronouncing it badly. But I'm very honored that you're here, and you will share with us your expertise and experiences in a plenary talk, talking about how the Central Arctic Ocean Fisheries Agreement came to be and how it could move forward or maybe not move forward. Then we are having 3 normal 10-minute science talks afterwards by very excellent speakers as well. So we will have then a talk by Agnete Fransen and Bodil Bloom, a shared talk by them both, talking about the diversity of the different basins in the Central Arctic Ocean. It's a huge area. How does the morphology of that Arctic Ocean maybe have different results for resource management? We also have Connor Rettinger with us. Very pleased that he also traveled a long distance for us. So he's going to talk about the framework for risk and residual risk adaptation. Very interesting because it's something that's also coming out of the latest IPCC efforts. And then Bodil Bloom will again wrap up actually the talks, talking about, well, we might always forget because we don't always see it. It's the benthic habitats and the biodiversity, and something we should definitely not forget. And then we will have the panel debate moderated by Liz Jørgensen from the Marine Research Institute here in Tromsø. And yeah, at least I'm excited. I hope you are as well. And I don't want to take too much more time introducing the section. So I welcome you all. I ask you to mute your phones. That would be very nice for the speakers. And I also ask the speakers to have once a while at the clock, so I don't have to go and push you off the stage, because I would not like to do that. So with that, I give the floor to Hyung Chul Sung for the plenary talk. The floor is yours.
There and okay.
You know, this is for the next slide.
Right. First of all, I very much appreciate this opportunity to talk to you this morning. Now, I will be speaking about unlikely success in the Arctic Ocean. My case today will be Central Arctic Ocean Fisheries Agreement. Now, this is, okay, polar waters are not as pristine as one might think. Also, fishing in those waters is not something very new. This is what you get to see when you walk away, say, less than an hour from our Antarctic station. And, okay, these are whale bones, right? As early as 1920s, people went down to south to hunt for whales, and drove many of the species to extinction. And then typical happens. You go on to the nearby waters or next large species. And then cod, it's very easy to get a collapse of this species, like this. And this is what I had a couple of nights before, Norwegian stockfish. This is Korean stockfish, very similar. But anyway, they are not the same species, they're cousin, walleye pollock. Again, in this donut hole, in this international waters, you had, again, collapse of the walleye pollock fishery in the Bering Sea donut hole. Okay, then we don't want to repeat these mistakes in the Arctic Ocean. You know, this is actually the sea ice laws starting from 1979, where you had the first satellite technology, and the polar bears are coming, advancing, but they may have no sea ice to walk upon. But still, there is a rosy expectation that are being depicted. Some nice commercial species might move up too. But before that happens, now this is in Science News article 2017. Nations agreed to ban fishing in Arctic Ocean for at least 16 years. That was a result of 2 years of intense negotiation. And then this agreement kind of concluded it and wrapped up 2017, and 2018 it was signed, and then 2021 it entered into force. Okay. Now I will be talking about the significance of this agreement and historical account, how it came into being, and what was the timetable and the requirements, and what were the outcomes of the recent Conference of Parties meeting, and then I will wrap up with some future thought. Okay, again, bigger donut hole, larger than the small donut hole that we had a collapse of walleye pollock fishery. Currently, no current commercial fishing in the Central Arctic Ocean, but climate changes, warmings, and enhanced accessibility may change all that. And there was an urgent need to, any future fishing has to be sustainable. So the core of the agreement is precautionary approach and ecosystem-based approach and governance, which also integrates different knowledge systems, Western modern science and indigenous knowledge. You can actually see this kind of clause and articles in the agreement. So you don't authorize your vessels do any commercial fishing in the Central Arctic Ocean. And then you need to know first enough, and then you are required to integrate the scientific knowledge and indigenous and local knowledge. The history is longer, much longer than this, but anyway, from 2015 there was a declaration. But it was only 5 Arctic coastal states, Arctic states that has their coastline facing, their line facing toward the Central Arctic Ocean. Then there were 2 years of 6 rounds, in fact, 6 rounds of negotiation among 10 governments. 5 of them were Arctic coastal and 5 of them non-coastal. And then again, 2018, 10 countries signed the agreement, and then 2021, a little more than 2 years ago, it entered into force. Now, from this time, there's challenges, COVID-19, Ukrainian aggression, and all those things. But we somehow managed to have the very first inaugural conference of meeting in Korea. Then we had, again, in 6 months, we had second conference of parties meeting. this is my thinking. So let's say it entered into force 2021. As I said, 16 years of moratorium at least. Then it will become 2038. Let's say this is 16 years. And if we just split it by 8 years and 8 years, half and half, my guess is that more than half of it will be time of science, time to accumulate knowledge base. And maybe less than half of it, it will be time of more governance. But the requirement is you need to have a joint science program in 2 years, and you need to have measures for possible exploratory fishing in 3 years. That is the requirement of the agreement. And in the end, at the end of the day, like 16 years after, you will face time of choice and decision. Maybe 3 ways. CALPHA, this agreement continues, or you may have a new organization or arrangement in place, or you just give up on this agreement. So anyway, for scientists, it will be their time. And then, this is as I explained. So to make it short, we managed to have joint program developed in time, and we ought to have exploratory fishing measures by this year, June, and we will probably have it done at the third conference of party meeting. And another requirement was to have a scientist meeting in actual form of like science body, and we had that too. Now, I'm not going to explain in detail what outcome came out of each conference of party meeting, but the first meeting was a success. In some 75 people came to the meeting with all 10 parties, including Russia and some observers too. And then we endorsed reports from provisional scientific coordinating group, and we also adopted rules of procedure. And then at the first meeting, leadership was formally established. We elected chairperson and vice chairperson, and chairperson and vice chairperson for the science body. And also we established 2 different working groups, and we distributed chairs to each working group. And then, as I said, we were expected to conclude or develop some measures for possible exploratory fishing, and then we came up with a virtual drafting group to write down the questions we need to answer to develop measures for this purpose. Now then, when we were finished with the first meeting, we had a calendar developed, then future meetings, and then it all happened on schedule. And then from the second meeting, about a half year later, as required, we developed joint scientific program and joint program of scientific research and monitoring. And also, we concluded the rules of procedure for the science group, and we distributed members to 2 different working groups. And then, to make it complete, we will have third conference meeting in this coming June. Now, my talk is quite short today. Now, what I would like to emphasize, this all took place on schedule. As required, as stipulated by the agreement, amid outbreaks of COVID-19 pandemic and the aggression on Ukraine. Everybody knows that we cannot do this without Russia, but are we happy to have Russia, or will Russia come? Big headache. But somehow we had it done. Now, I think what we confirmed and what we learned out of this agreement was a unique milestone in terms of precautionary and ecosystem approach, Arctic cooperation and governance, and also inclusion of indigenous knowledge in a very official way. We have something very well developed at the other side of the Earth in Southern Ocean. There is an international convention called CAMLR, and they have a very well advanced institutions and systems in place. But that was something after the very heavy or serious lesson after you draw many whale species and seals and to extinction. But this time, we could somehow prohibit fishing even before fishing starts. Okay? And it should have implications for broader conservation cause in the Central Arctic Ocean. It doesn't have to be fishing. Now then, what we found, science, there are already national programs in place, so there are existing foundations we can develop upon. And we can have this existing foundation aligned and tailored for future needs. It's just up to how we do this. And indigenous perspectives were introduced, and also we had, in many cases, already success stories available from Canada, like studying beluga whales in collaboration between government, Western modern scientists, and indigenous people. And also in this process, we had a fair bit of learnings and cooperation from our own ground, our Central Arctic, also from the other high seas, including Southern Ocean, Antarctic Ocean, okay? Now, when it comes to indigenous knowledge inclusion, this is not just a matter of having two groups sit together. It's a lot more difficult, more challenging. You have indigenous and local knowledge at one side, and also you have big toys like research, icebreaker, and plankton nets, but you get them together and put it into puzzle, but make all the pieces falling into right places. This is a challenge, but we will have to get it done. Now, for me, CALFA, the agreement, is a testament to the power of scientific cooperation and knowledge base. And I think the success is due to willingness and close cooperation by the parties and indigenous groups. The parties include Arctic coastal states as well as non-coastal states. The agreement has brought together both Arctic coastal states and non-Arctic governments, including EU. And we also found, as I said, a good number of Central Arctic Ocean related initiatives around and on the table. And this actually provides a chance for us to align national programs and campaigns. Now, current progress for this agreement, there are working groups on the go very actively. For example, Science Body has now 3 working groups. Mapping and monitoring and data protocol were the original 2 ones that we were going to have anyway, but we now came up with a 3rd one because the science group had to provide questions to feed into the deliberation of the conference of parties, commissioners, to develop measures for expert fishing. So 3 working groups for the science body and 1 working group for the commissioners, representatives. Now, as I said, the 3rd conference of party will take place in coming June, again in Korea. So this momentum, upheld by all parties and all stakeholders, will continue. Now, well, again, this is painting from a Korean artist. Now, I think what we are expecting to see and what we are expecting to prepare for is future Arctic Ocean, new Arctic Ocean. Animals, ecosystem, whales, and also people who have lived in the area thousands of them. But new, oops, but no, humans are entering with sextant. And we might do something like tourism, fishing, mining, but how we are going to have the future Arctic Ocean in peace and in balance, in harmony, that's the question. And so here's my last slide. Again, precautionary approach, ecosystem approach. You have to know first before you act. In other words, before you do anything stupid, before you do anything you will regret later, you need to know enough. And that should apply not just to fishery, but any form of human activities that might occur in the Central Arctic Ocean. And see it as a whole. You don't get to see only fish species, but the species who are eaten by fish or the species who eat fish. And it's not just about shipping, sound, noise, pollution it might cause. So whether shipping, mining, tourism, plastic pollution, whatever, know first before you act and see it as a whole. I think these two messages out of this agreement should apply to all future use of Central Arctic Ocean. Now, here is my two conclusive thought. You need to have a mechanism of dialogue. You need to talk. Somehow, in this course of 2 years of negotiation, a dialogue was possible, including every 10 governments. And then, so through this mechanism of dialogue, we had an agreement, but to get it run, we need to have a machinery implementation by individual, align them and coordinate them. Then maybe not just this working, but relevant science-operated institutions should get together and talk. I think I'll stop here. Thank you.
Thank you so much for this really inspiring talk, I would say. I think it's very inspiring to see how knowledge matters and how we can use it to come to large-scale agreements and make conservation happen. So thank you so much. And we have 2 minutes, so if there's immediate questions in the room, we could actually take 1 or 2 questions.
Hi, Bodil Blum, UIT. Very, very interesting talk. Thank you. I was curious, you mentioned the exploratory fishing or the filling gaps through fishing in the Central Arctic to actually gain some of that knowledge. And I was wondering if there's discussions on what scale it would take and how would that happen, and would it happen in a coordinated fashion so that not all the 10 or other nations go out and do their own thing? Is that an issue or a topic of discussion in those meetings?
My real, my guess is it's not going to happen very quickly because it just is costly. But I think before you have a very detailed mechanism, like, okay, you do exploratory fishing here, but you catch this amount and you move to the next area, and if you catch this amount unintended vulnerable species, you have to move. Before that, I think we will need to develop guiding principles because you don't have a biomass estimate and you don't know about the related species, the behavior, ecology related species. So you need to have guiding principles developed first. But I think that will be measures we will develop this coming season. But if there is a potentially fishing fleet coming into the areas, then we will need to have a more detailed one. But unless it is somehow commercial incentives are provided by external force, then it's not going to be realistically feasible to see explorative fishing in the near future. There was one question at the back. Yes.
Thanks for a very interesting presentation. Thanks for an interesting presentation. My name is Håkon Hopp. I'm at the Norwegian Polar Institute. There's only one minor problem. There's no no pelagic fish in the Central Arctic Ocean. It's just about totally empty. So do you think that will actually make it easier to extend the moratorium in anticipation of that the fish would potentially move in there? I mean, we have been doing exploratory surveys with echo-sounders and pelagic trawling all the way to the North Pole at the Polar Institute. And I can tell you, once you get off the shelf slope, there's no fish, pelagically.
Yeah, pelagic-wise, but also it is true that we didn't cover all the portions of Central Arctic Ocean. And the Central Arctic Ocean is one single identity, especially when it's closer to the coastal, like shallow depths, it's just different. And we actually got to see not entirely benthic, but the benthopelagic fish in our survey. And we also got to see some king crabs. This is something that we didn't expect to see. So you will have to see, yeah. But so far, the surveys didn't reveal too much pelagic fish biomass. I considered that.
There's a lot of uncertainty in this region. That's very true. So, but we're going to clear some of that up with the next presentations.
Okay.
So we'll do a little mic switch, actually. So we have two prominent ladies actually gonna at the forefront of the Central Arctic Ocean. So they will give a shared talk. Bodil Blom and Agnete Fransen, please come to the stage. And they will, for sure, I think, fill some knowledge gaps that we have already brought up here. So while we're getting ready.
Do you hear me? Yeah, it's on. So thank you very much for this nice introduction, and we are so happy that we got the opportunity to talk about the Nansen and Amundsen Basin, and also about contrasting physical chemical properties and biota composition to inform management. So you have to do now. We will learn a little what Håkon mentioned here. So this was this presentation we will be shared with Bodil Blom and myself, and it's based on the Nansen Legacy Arctic Basin cruise that we did in 2021. And the Nansen Legacy is, as you probably know, this a huge Norwegian project that is funded by the Research Council of Norway. And it consists of several Norwegian institutes and university. And yeah, you see all the logos and all the names that actually co-authors of this presentation, and also a manuscript that we are currently working on, led by Kolbach. So here were the group of people gathered in Tromsø, and we were so happy to go on this first expedition into the Arctic Basin. So we went to Svalbard and started north of Svalbard, or in the northern Barents Sea, on the slope, going into the basin. So it's the P7 station. You see on the left-hand side, and then entering the Nansen Basin, go to P8 and further in on the Gackel Ridge and further into the Nansen Basin on these two P10 and P11. And we also, these process stations that we took all kinds of samples that we could. And we also have some stations in between that we could also see the end-leg stations here. But this area in the Nansen Basin is mainly influenced by the warm and relatively saline Atlantic water with lots of nutrients. So you see the red, yeah, it's very strange. Yeah, the red current there on the map in the middle, and it goes into the Nansen Basin. And the Amundsen Basin is different because it's more dominated by the fresher transpolar drift. It's also affected by river water from the Eurasian shelf. And yeah, so we will show some environmental variables of sea ice, water column, and sediments. And we also call that sympatric, pelagic, and benthic. And to show biota in these realms under current conditions to inform resource and conservation management. So the sea ice conditions in the area, was you see the map in the middle, is the black color means that there's no sea ice at all. So the white is the sea ice, and on the first station on the slope, we didn't have any sea ice at all. You see the black P7 in the black. And entering the Nansen Basin, we approached some mixed ice types and also some ridge ice flows. But the further in we got into the Amundsen Basin and into the Arctic Basin, we approached thicker ice and also really dense, rich ice. So the mean average thickness in the Amundsen Basin or further north was almost 2 meters thick, while on the average in the Nansen Basin it was about 1 meter thick. They were compared with these flight measurements we did with helicopters, and we had the helicopters on board on the ship Kronprins Haakon. This you should see on the pictures here. So the hydrography and chemistry was they were different in the two basins. The Nansen Basin you can see on the left-hand side, and the Amundsen Basin on the right-hand side. And it's from the top to the bottom of 4,000 meters. And it's actually split a little bit in the middle there, just to cover, to get the focus on the surface water, where we actually in the Nansen Basin can actually observe this influence of this warmer and more saline or salty water in the surface. It was also higher nitrate concentrations, and it was also reflected in the higher chlorophyll. To see the panel at the bottom with more green color there in the Nansen Basin. While the Amundsen Basin was higher silicic acid and dissolved inorganic carbon, but less chlorophyll, and was fresher in the surface, and we could see signs of transpolar drift. Okay, so there we also found the mixing of nutrients, that it was larger or more potential for mixing in the Nansen Basin compared to the Amundsen Basin, and that was also reflected in the primer production that we observed with a higher concentration of primer production in the Nansen Basin or in the slope specifically compared to in the Amundsen. And Amundsen had less mixing and more stratification and also thicker sea ice. So yeah, so now I go to the next speaker.
And that pattern and primer production and nutrient mixing then is reflected in the zooplankton stocks that you see on the left-hand side. I could just use my old-fashioned finger because I don't actually see the pointer on the screen. So on the left-hand side, you see small copepods, larger copepods, and the gelatinous zooplankton. From the Nansen to the Amundsen Basin, you see clearly the higher stocks on the Nansen Basin side, especially near the Atlantic water inflow. You see that both in abundances, which is shown here, but also in composition. So for example, here the Atlantic water mass tracer, Calanthus spermaticus, which is actually not the species on the picture, but also here some gelatinous zooplankton, so we can use both abundance and composition as tracing this water. Low stocks on the Amundsen Basin side, but you see that some taxa, like this jellyfish, for example, is actually more abundant there. Now, as for our fish, that fills sort of information gaps that we were just mentioning. And I'm not even showing a graph because you can see, maybe, here are our fish, 2 of the 7 individuals that we caught. Of 3 species, representing 3 species, one was actually a new record, the Greenland halibut, a larva. So much for fish. And then we also found some species that were detected for the first time that far north. Now taking that to the sea floor, this is in the water column, what happens to the sea floor. Too many things on the slides, but I just wish to draw your attention to the left column here. We have algal biomass in red dots and algal cell numbers in the bars. And then the second figure here shows the vertical flux, so what of that sinks out to the bottom, resulting in how much biomass. So you see, again, in our Nansen Basin side, especially on the directly Atlantic water inflow side, you see that higher stocks in the water column facilitate stronger vertical flux and results in slightly higher benthic biomass, even though the numbers are extremely low compared to the shelf. And low values on the Amundsen Basin side, but really overall quite low values. And what happens in the sea ice is shown here. from Nansen Basin to Amundsen Basin. We have show you here bacterial numbers, protist numbers, ice myofaunal numbers, so a lot of the small things. We show you also rates, bacterial production in the red dots, primary production in the triangles. What you see here is that the ice that was over the ridge at the time that we sampled it actually had the highest numbers and also rates. So that station, as Agneta showed earlier, where we sampled it, was wedged in the other ice stations, but had a different origin and a different lifetime than the other ice flows. So here the ice origin has much to say, or maybe even more to say than the basin differences alone. Now, what are implications for management? So I think we've shown you, or tried to show you, that there are differences between the Nansen and Amundsen Basin, and that that is relevant to take into consideration when management strategies are developed. And in particular, that this area north of Svalbard in the Nansen Basin should not be considered representative to the entire Eurasian Basin or even to the rest of the Nansen Basin. So when we place our locations that we monitor, that's really important to keep in mind, that we don't draw inference from that location to the entire basins. We did not find indication that a fishery can be supported in the Central Arctic Ocean. And we are finding some indication that borealization also has reached the Central Arctic Ocean, meaning that species that weren't there before can show up, but of course that's always biased by our knowledge stage at the time. And of course we wish to thank the Norwegian Research Council for supporting the Nansen Legacy in addition to the institutions that are part of it. Thank you.
Thank you so much for squeezing this huge research program in 10 minutes of presentation. That's a big challenge. It impresses, of course, the amount of knowledge that's created. And so, yeah, thank you for that huge job. And I would also like to instantly invite the next speaker on the stage. So you get your microphone still. Yeah. Because when we have a lot of knowledge and we want to do management policy, we need to know what's the risk associated with the activities we actually do there. And I think everyone agrees this is an ecosystem that's going to change a lot because of the climate change. And so it's a very big pleasure to invite Connor to the stage, who is going to talk about the risk framework and how it relates to climate change. The floor is yours.
Thank you, thank you. Can everybody hear me? Perfect, all right. So my name is Connor Redinger. I'm here to present the Residual Risk and Adaptation Database. So let me see, this is kind of working now. Okay, perfect. So I just wanted to thank our partners just to begin with, because I know that it's a 10-minute presentation, so I want to thank the IPCC, specifically the AR6 working group, the Chapter 14 and Chapter 6 authors. I want to also thank NOAA Fisheries, ArcticNet, and the ESPG group, all for their collaboration, their help, and their funding. So just to give a little brief overview of our project team, we have Dr. Jackie Dawson and Dr. Kristen Holzman as our team leads, piloting this, helping manage this project, and our team members, including myself, is Sierra Beecher, Lyra Evans, and Selena Edmund Dua. And so just to give a brief overview of what we're talking about is, you might be asking, well, what is RRAD? So I'll be diving into why we created it, what it is, as well as the next steps as to how we can further improve this, as well as key milestones and timelines throughout this project. So initially, RRAD was created at the end of the sixth assessment of the IPCC report, and what we really understood was there was emerging knowledge gaps, specifically when researching and assessing those residual risks, adaptation, and mitigation measures. So when we were looking at different chapters, each chapter had their own way of collating adaptation data, which is and can be problematic in the future when in correlation, when we're looking at risk and residual risk. That has already been kind of formalized, the definitions have been standardized. So this is how kind of the RRAD database came into fruition. So this is actually a photo of the RRAD database, to just the first title page when you see it. But basically what we were trying to do is create a systematic and traceable approach that really supports those efforts of assessing and identifying, quantifying adaptation in multiple key areas. So hopefully what we're hoping this product is able to do is it's really able to be used across disciplines, across industries, and hopefully whether that be in government, in NGO use, or even the private sector. We're really hoping this tool is able to be utilized everywhere to quantify adaptation and also use it to assess risk and understand risk better. So just before we go, I want to kind of get into a little bit of details as to how we are defining residual risk and risk in general. So as you can see on the screen, risk is in the middle of this diagram with hazard, exposure, and vulnerability kind of influencing those. One thing that we realize is that mitigation mitigates the hazard aspect, and adaptation measures really look at the vulnerability and exposure. And after that, once those two measures are kind of placed in together, then you see the residual risk right in the middle, right? So a quick example of this would be looking at sea ice and specifically Arctic shipping. So a risk would be looking at a vessel sinking. So a hazard of that would be a climate impact driver such as sea ice, multi-year sea ice, and the vulnerability and exposure. The exposure would be, well, when are we going? And vulnerability would be looking at potentially the ice classification of that vessel to see how vulnerable the vessel is to that risk, right? So mitigation and adaptations would be applied to then create that residual risk. So again, why do we create RAD? Our RAD was because it would help facilitate and create a systematic approach to the assessment of literature. So hopefully, once we create that traceable approach, we're able to really connect it, one, to the Sustainable Development Goals and in risk evaluations, but also hopefully able to streamline those efforts into future assessments, specifically hoping to help create a framework for AR7 that's hopefully going to be published by the end of the decade. And so when we're looking at how to use it, it's great to know how to use it. We use RShiny, which is available in RStudio, which is able to be downloaded either through the GitHub, or you could use an online tool using an available link, which will be soon published. So once we have that tool available, you'll be able to enter all of your reference details, all the authored publication data, and then once you enter all that information, that's when you get into the hazard, risk, mitigation, and adaptation measures. So you include those as well. And so once we've created that and collated that, it comes into this big reference column where we're able to have the citation, have the thematic group, have the different categories of hazards, risk, and adaptation, and really understand and start to put all the information into one database. And what it ends up creating, so from this database, we create different summary plots based off of all the data collected. So that's looking at either sectors, or that's looking at the top thematic group areas. So when we're looking at that, they're presented right now in a radio plot, showing and highlighting the excessive amounts of risk in different subject areas. But basically what the premise of this is to really make it an ideal tool for people to quickly scan, look at a general topic, and even download the data for citation and further evaluation. So then you can really look at the different articles that are summoned and identify, okay, well, let's learn a little bit more about this. Let's dive deeper into this, right? And not to mention, that was the risk and residual risk side, we're also looking to quantify the adaptation measures. So within adaptation, what we've created for our framework so far is we've looked at feasibility, effectiveness, and mitigation measures, all kind of mentioned previously in the presentation. And specifically within feasibility, we're looking at economic, environmental, institutional, and sociocultural factors that play into those. So all those kind of gray topic areas for feasibility as well as effectiveness, we are looking at those and we are creating questions to really kind of start to assess whether through those articles that we've selected and that are in the database, whether they meet those requirements for feasibility and effectiveness. So I didn't touch upon effectiveness, but basically what they're looking at is reducing risk and vulnerability, looking at resilient communities, looking at the economic implications and whatnot. And hopefully what it creates is that nice adaptation kind of triangle, right? And this is one of our diagrams to really indicate how well the adaptation is succeeding or potentially where the shortcomings are. And there's a couple of factors that we were really looking into that kind of influenced all three of those different pegs in this graph, and they were co-benefits and time frame of implementation. So when we're looking at the co-benefits being are the communities seeing, or are these adaptation measures seeing a net positive development, a net negative, or net neutral? So that can definitely be seen throughout the feasibility, effectiveness, and mitigation. Another aspect to consider was time frame of implementation, because obviously the longer the adaptation measure takes to implement, the amount of time and the rate of change or uncertainty also is fluctuating too. So when we're looking at those adaptation measures, this is how we would see the uncertainty kind of unfold, whether that be a level of confidence. We can see either the feasibility or effectiveness have that variability based off of the time frame in the co-benefits analysis. And so just to wrap things up, I just want to also say, from all the information I presented to you guys, we are definitely looking at feedback and consistent feedback. So if you guys have any questions, comments, feel free to reach out to me. But some of our future timelines and outcomes is that we already have created the R code to really create those radio plots, those residual risk plots, and as well as the Shiny dynamic output and plotting tool. So this is really compatible to Google Sheets. So when I was talking about downloading those references, that's the document that would be available. So it's accessible via online. And then some future steps for us is we're really trying to finalize that adaptation framework by the spring, looking at the Shiny demo and trying to launch that and create a live version of that, as well as the GitHub repo for figures further analysis, as well as a publication for methods as well. But that's still in progress, so we're holding off for a date and deadline. But yeah, I just want to say thank you.
Thank you so much, Connor. That's a very interesting out-of-the-box thinking framework you got here. We have a minute for a question. Should there be one from the audience before we move on?
Someone in the very back.
I'll run to.
Yeah, thanks. It's very interesting.
Welcome.
But I have to have a microphone. Thanks, Igor. It's very interesting. Do you need R as a ticket to the entry door to get in?
No, so you don't need R to get in. So with the live version, you're actually able to access it via the link. Sorry if I was yelling for a minute. I was just trying to get to the back of the room. But basically, so you don't need R to download it. That's also, in a sense, for industry professionals that may see this is great, but I'd like to improve on it. So if they have the tools and capabilities, we're really trying to just create a tool for people just to either utilize or just create it to meet their needs for assessing risk, residual risk, and adaptation. So that was kind of the premise of the project. So you can use it either way. Any other questions? Or even comments or feedback? I'm more than happy to receive feedback.
I will ask people to go and, but can you ask it in the panel or? Yeah, so I just for the sake of time want to keep a lot of time for the panel, so you can choose if you do it now or later. Later then. Okay, thanks so much, Connor. So after that deep dive into some methods of risk assessment, we're going to also take a literal deep dive into the ocean this time. So the last scientific talk, before we move on to the debate, is presented by Bodil, and the title is everything there, so perfect.
Back to the finger. Yes, I take you to the Arctic seafloor here, representing both the Challenger 150 group, that's the Arctic part of a UN Ocean Decade endorsed effort with representation of the Nansen Legacy. And we dive right in. Why would we care about the seafloor? It's deep down there, but we've had a couple of good arguments why we care. We have a number of agreements, like the fisheries agreement, with the map that we've seen earlier. We've seen this kind of map earlier in the political decisions here in the Nordic seas, where the very seafloor is of interest, in particular to Norway and mineral exploration discussion. Right now we also have international agreements, like the 30 by 30 agreement. So there's many reasons why we need information about also the deep sea being the largest habitat on the planet. So we set out to update the knowledge of what lives in the deep sea, in the Arctic part of the deep sea. In this case, we take the Nordic seas and the Central Arctic Ocean, building on what probably I think is the first inventory by the Russian Academy of Sciences from the St. Petersburg-led group by Borosienko in 2001, where we already knew there were hundreds of species living at the seafloor that once we thought was sort of dead. 10 years later, out of the Sense Marine Life group, working with the same group and many more nations from around the Arctic, we tried an inventory, made our dots on the map really big, so it looks like we know a lot, but actually if you make the dots smaller, we actually don't know that much. But we did find, just with another inventory, another 400 species more, so we know there's over 1,000 little things or bigger things living at the seafloor that many of you and us have not seen, but are there. We don't talk about bacteria and microbes here. So a few years ago, we set out to do a new inventory using these data that mostly are now archived in the Global Biogeographic Information System, GBIF, and the Ocean Biographic Information Facility, OBIS, in addition to contacting data holders that we knew had additional data and combined those data into an inventory that resulted in yet another 600 or so plus more species. So we're up to about 2,000 species that are at the seafloor deeper than 500 meters. And now that we had sort of an updated inventory, then we went to compile a habitat inventory looking at not just taxonomic inventories, but also habitat diversity, which is really important these days, and maybe always has been, but even more so. So this is a resulting map. This is taking individual GIS layers and combining them into a combined map that you see here, where obviously the ridges are prominent in those yellow-ish colors and are quite of importance in the discussion. One thing I want to draw your attention to are all the triangles and the circles that have popped up in the last years. They haven't popped up, but in our awareness and knowledge. And so what we now recognize that there's a lot of seamounts, that there's a lot of vents, especially along the ridges, but seamounts, of course, elsewhere as well, that are both in the Central Arctic Ocean, but also in the Nordic seas. And only a few of them have been biologically explored, but some have. So putting these two things together, we can now begin to look at, and we haven't fully done that, but at least started in this article that finally got submitted, to look at which animal groups or living thing groups are in particular occurring at certain habitats, or are they specific to a certain habitat? What might be occurring specifically at ridges or other habitats? I'll just focus your attention on the ridge graph here. So basically what you're seeing is the composition of the occurrence records of a particular worm at a location in these different habitats, and these are our different animal groups down here. So what you see for the ridges, which now include the seamounts and these vents, you see, for example, that there is a lot more sponges in those areas. Has to presumably to do with the currents being slightly higher at the seafloor around ridges. And that, of course, is they form, in other assessments, often vulnerable marine habitats. Why have we learned more about, in particular, ridges and seamounts? Here I name a number of efforts from particular regions from the last years. The Aurora vent field on the Gacko Ridge has yielded a whole bunch of new species and vent fields in the Arctic. The Crassic Seamount, which is a seamount on the Gacko Ridge, various seeps, and also the Chukchi borderland area north of the Chukchi Sea have been explored to some extent. And what they actually look like in real life is what you can see here. A picture from one of the vent chimneys here on the Aurora vent field on the Gacko Ridge with the Reef Ocean ROV showing a number of new species of little snails and little wormy things. On the Crassic Seamounts, you find these sponges that actually crawl around and use ancient carbon from previous seeps. Very interesting life forms, and that way sustain biomasses, so amounts of matter that are much higher than otherwise you could sustain with phytoplankton-derived matter. Sponges also in other areas on the seamounts here, for example, on the Gacko Ridge, and very heterogeneous habitats in the Chukchi borderland where we see lots of habitat in one little place. So, point of that is there's a lot more habitat diversity in the deep Arctic than has been acknowledged before. Yet, if we look at how much we do know,
about this fauna. You look at two plots here. On the one side, it's the amount of records, so how many distribution records do we know from in a gridded matter here from this area, and then how many taxa did we learn there exist in those areas. And you see that the yellow colors predominate. So in most areas, we know nothing. Still sort of frustrating. So where we have few animal records, of course, we believe that there are few taxa. But where we have done more investigations, such as the Norwegian slope here, we find a lot more living things. Well, the more you look, the more you find. So in other words, we're not done. Keep going. Where do we find most taxa so far? Well, most of the distribution, most of the sampled areas are in the upper 1,500 meters. Most of you working in the water columns know you don't really like these benthic pico because they use up all your time and they may mess the deck up with dirt. And so that's why we rarely get down to the deeper areas where few examples exist, and that makes us believe that there are few species there. So we end up with these kinds of curves, species accumulation curves, or more samples taken yield more species there. This is by number of different groups. We don't reach an asymptote in any of those areas. This was from the Sensor Marine Life a decade ago or more. Exactly the same graph now, more or less. The numbers maybe have changed a little bit, gone up a little bit. But basically, we still haven't reached an asymptote. Asymptote would tell us that we have probably covered all species that occur in an area. So we have not. We also see that we have seem to have more taxa in the lower latitude, 70 north, than at the North Pole, where it looks like we know everything. We're not quite sure about that point there. But also, of course, this is not scaled to the ocean area, so it's not standardized to area. Those pictures show just a few new species described in the last decade or so, and it's not, to deep sea biologists, it's common to find new species. And we continue with that. What are the dominant groups? Those are our annelid worms, our arthropod crustaceans, like the little shrimps up there, and bivalves. Nothing new about that. There are dominant groups all over in the world's oceans. What you see in the red hatched bars are those that have been barcoded, so where we have a molecular fingerprint from the deep ocean, and that's really minimal, as you see so far. Okay, with this more complex slide, I want to hop to results from the Nansen Legacy and show you that we also move from taxonomic inventories to function. What do they actually do? And so the left plot is the community structure, so similarity plots in a multidimensional scaling form here. Shelf taxa here, clustering relatively close together. Our deep sea taxa are all spread out, are all kind of different, although they're more or less taking the same place with the accuracy of a ship. On the right-hand side, we see the functional similarity where we've coded them for different functions of what they do. So again, what I want you to see is that the shelf groups clustered together, our deep sea ones are all over the place. So they do something else. They have different functions. And so in management, we need to account for that. There is reason to believe that there's a lot more data going to come out in the next couple of years because all these expeditions have happened in the last few years after our inventory started. Partly as part of the Synoptic Arctic Survey, many cruises out there in addition to other surveys. And so we will learn more as the years go on. So I leave you with a few take-home messages here. We filled some knowledge gaps. We have a lot more gaps to fill. Thank you.
Thank you so much, Bodil, for showing us what's maybe not always obvious when we think about the Central Arctic Ocean and share with us what actually lies beneath the sea surface. Timing is perfect, and so that's really nice for me as one of the organizers today. I would like to now also invite later on all four of the speakers, but before that I would really like to ask for an applause for the excellent science that they've presented here. So, as I said, we'll have a little panel debate up front, also to continue talking about what's maybe not so obvious when we think about ecosystems, very complex subjects. How do we actually manage the ecosystems? How do we bring the knowledge forward to conservation and to make sure that policy and the public is interested in it? So for that, I would like to ask Liz Jørgensen to come to the stage, and she's going to give a little bit of a introduction to the panel debate. So I will hand over the microphone to her now.
Yeah, I can do. So thank you very much, Igor. Thank you so much for these very interesting presentations that you had. Something directly for the Central Arctic Oceans, other little bit aside, but still very relevant. I go to the stage. So I would like to invite actually our 4 panel speakers up here and ask you some questions. And actually, I'm not asking you questions immediately. Actually, I would like to show you a presentation of a paper that has just been submitted, and that will be our entrance to this discussion that we will have for the Central Arctic Ocean. So if you go to the next slide, or somebody press the green button that we had. It's right here. So this shows you a map that was actually written by Dawson, your professor in Canada. She shows here that in the red area, and if you focus on the map, you will see this is the Central Arctic Ocean that is delineated in this dotted line. So we have some red areas in north of the Barents Sea, but also north of the Bering Sea, north of the Chukchi Sea. And the high red area will be area where we have several species that are in risk. And if we ask ourselves, so what type of risk is this then? And from what? And if you look at these lines that is behind, these lines going across the Central Arctic Ocean, this will be ship tracks. So this is species who are in risk for these ships doing these tracks. So this is not completely true that ships are doing everything, because from a can I stand down here? I'm very afraid of falling down. This seabird, what? It doesn't see on this. Oh, sorry. Just tell me when I get close. This is a curve showing you that the total amount of risk is higher the higher you are on this axis here. And you have 4 different human activities. So it's global sources coming in, research, military, and tourism. And if you go for the global sources, which is bringing pollution into the Central Arctic Ocean, we see that seabirds have a bioaccumulating effect and then accumulating contaminants within their body. So that is risk number 1. If you look at research, actually we see that noise, not only from research, but also military and from tourism, are causing some issues or risk to sea mammals that are impacted by noise. So noise and sea mammal is the other one, while we have a last one, and that is actually from our own research activities, and that is that we extract species. And there I will come back to you, Bodil. You see that you're telling that we are actually still finding new species. So these new species that we find, do you think that any of these can be exposed for the risk of us self, the research, having an impact on them that is negative?
For the question, of course, I don't want to stop our research. Oh yeah, wrong microphone. Yeah, that's a good question here, Lise. I think maybe I'll go beyond the research impacts, but general impacts at the seafloor. Mechanical impacts at the seafloor will, of course, in fact, affect the seafloor in the matter, at least in the location where they actually happen. And I think there's a few things we should consider for deep sea taxa in that context, and that would be one, now we have a recognition of these different habitats and also biogenic habitats, so in cold water reefs, coral gardens, sponge gardens and so on, actually being there in the deep Arctic and the Nordic seas. 2, that we know that these cold water and Arctic species tend to grow slowly and live longer. So that suggests that there is recovery rates are not going to be very fast, depending on the type of impact. 3, we know that densities are generally lower than on shelf seas, for example, but that they can be concentrated in areas such as vents, which happen to be on ridges that happen to be mineral rich, which of course makes them interesting for industry. So that all in combination, we should consider what activities are okay. That's a value judgment in the end. We do know from physical impacts on shelves from trawling, for example, or other mechanical impacts. Of course, there is an effect on biodiversity, typically a decrease, and a shift in communities. There is an effect on the functions and on the carbon sequestration, as we heard earlier in one of the talks of the seafloor sequestration. So whichever impact there is or will be needs to be evaluated sort of holistically, both for the small scale where an impact happens, but also what is actually the footprint of a particular impact. I think that's kind of a bit more unclear at this point to evaluate whether it's for the footprint of a science sample of a 0.1 square meter, we know what that footprint is, but for a footprint of a large machinery exploring or going over the seafloor, that's a bit of a different matter.
So we heard Hong Xiong talking about exploratory fisheries. What do you think about that? I guess that exploratory fishery will not be in 4,000 meters, but at fishery depth. And you show that the Chuk Chuk borderland could be an area for such.
You're looking at me? Why are you looking? Okay. For inventories or studies that we've done in the Chuk Chuk borderland specifically, and others, of course, as well. They've been a focus from a number of different countries in the recent years. One, I just want to stress that heterogeneity inhabited there. So it's ridges, it's slopes, it's basins in between. It's extremely complex. We're seeing, and as a result for that, the living things there, the biota is extremely heterogeneous. So it's really hard to conclude from one area to another. But what we do see in terms of fish there for demersal fishes, it's a deep sea. We see a fish here and a fish there, but yeah.
So more science, that's what you say. We have not seen the last species yet, and we still do not really know where they are. So this is actually what we can say about the benthic and the deep sea. So Agnete, you say that we have difference in basins. So you also say that we have to take that into account when we are managing human activities. So I also saw that you talked about more ice, less ice, warmer, less warm, more biodiversity, and so on and so on. So how do you see that impacting human activities?
Yeah, thanks for the question. It's good that you mentioned sea ice because, of course, as long as we have sea ice, it's really hard to go into the Arctic. We need icebreakers and we need that kind of more for the safety to go in there and strong ships. And but when the ice become thinner and we get warmer water and it starts to melt off, and more open cracks and leads, and it's getting easier for other ships to come, not only the research vessels, but also commercial ships like tourist ships, and also for deep sea mining. I don't know what activity that will in oil exploration. I don't know in the deep sea, but also these ridges. And also the banks that we also saw here in the presentation, that there are areas. So of course it will be more vulnerable for the ecosystem that lives there because it's a unique environment. And also this further, also of course on the slope where we have this intense productivity with this Atlantic water inflow, but also with maybe this will approach further into the Arctic as well, and with the new species coming into the Arctic. But there are less biomass, maybe yeah, so when the sea ice maybe becomes thinner or more open, more lights coming into the ocean, maybe a change in ecosystem too. So we don't know really how the situation will look like in the future with the primary production in the Amazon basin when the ice becomes thinner and more. Yeah, and you said the impact of human activity, and did I answer all your questions, Liz? Or maybe I should also say that of course we need to monitor still the research vessel. We need to go there sometimes to regularly to monitor to track changes. So I think it's still important, even if we contaminate ourselves, but I think it's in minimal form, and as long as we have international collaboration, we could cover different areas, and I think it's good that we also have in 2022 Arctic Ocean cruise by the Norwegian Polar Institute, and we also have coming cruise this summer. So we have started this monitoring that we need to actually track what's going on and to get advice to management and to these groups that you mentioned, this cow fishery agreement, but also to other groups. So so I think we need to be careful and think before we act, and as we heard, and I think and also maybe protect some areas, maybe also possibility for marine protected areas for other also for deep sea mining or other activities. But yeah, I don't know, do you have any other?
I need that. Thank you. So, yeah, thank you. But what I also hear you say is that we have more ice in one area and less ice in the other. So that will also tells us that, for example, marine animals that are depending on ice may be more vulnerable, will need another type of management. So we need to focus on that. So actually, yes, we will have different type of human activities management regime depending on the area. I guess that is the conclusion, yeah. So Connor, you was talking also about a thing that we as biologists don't think much about, and that is the social, economical impact. Would you say a little bit about more what we actually should focus on when we come to the Central Arctic Ocean?
Yeah, for sure. So I just want to say thank you for having me on the panel. And I wanted to kind of just jump upon the previous chat about how one thing that when we're looking at risk, specifically in the Central Arctic Ocean, we got to understand what is our human impact? What are we going into the Arctic Ocean for? So whether that be shipping, whether that we see sea ice change, tourism, resource extraction. So all those factors, we have to understand why we're going in, just so we can understand that, because when we're trying to assess risk and try to create a residual risk and adaptation measures, we have to really understand that this is a dynamic process. So throughout the entire process of adapting to the environment, or even just trying to assess the environment, we have to understand, well, what are we going in to do? What is our purpose in changing this environment, or even just being present in this environment? So that was one key aspect of risk that I wanted to kind of touch upon before kind of diving into my points. But when we're looking at key ecological and social risks, one thing that I really wanted to touch upon is we should be using the IPCC's previous subsectors and sectors, just to try to create a congruent and international standard among all data collection sources, just so we're really facilitating and really creating a data framework where we know where there's data sources available. We know that the type of data that's available, so then we can create and understand risk better. Did I answer your question?
Yeah, you did. And we are anyway talking about the same thing. We need more research. We need to put the questions out there. And now, Hung-Chul, you or you have not alone, but you are talking about the fishery agreement. But I guess it's obvious that it's not only fishery who are an activity in the Central Arctic Ocean. Maybe it's not at all a activity, and that maybe there's other activities that are more important or will become more important. So what about this agreement? Could that be expanded to include these types of activity too? I saw that you was talking both about precautionary, but also ecosystem-based. And here is the entire ecosystem.
I tend to think that this agreement can set an example. There are other institutions developing like plastic treaty and ocean treaty. So we can make all the things interlocking and complementary to each other. So I'm not thinking of having this expanded to cover other areas, but showing good implementation, then it can be a kind of setting an example for those possible future conservation measures. But here is one observation I would like to make. We have every reason to continue our monitoring efforts, but we cannot wait and produce a device until we know everything. It is very worthwhile to produce, if you like, interim report and see what we should be concerned about. So it's not a stepwise process, but it's all parallel, and we have to do things together. Let's say, for example, like this. I was part of this effort. When we did this, I thought we were doing out of very, very scanty data. And I was a little pessimistic, but when we got to see this, this was very worthwhile exercise. At least you know what we should be concerned and where we should put in our efforts. Like, so in this sense, is this going public later? Yeah. Let's say let's just assume that our policymakers are average intelligence, right? then there is no reason for us to be shy about producing a device and recommendations. Okay, so for us to do that, we need to be make it more digestible. For example, if we say, okay, 10 years ago we saw 700 species, now we see 1,200 species. We get to see more porifera here, more annelids here. That will not make sense to our policymakers. So we need to be more articulating, and we need to be even instructive to our policymakers. So not just monitoring, but this kind of effort is also very important and worthwhile.
And maybe also we need to explain why the Arctic is important.
Yeah, exactly. And I was just about to say, after your presentation, it really made me reflect a lot, is that even if we don't see a risk now, specifically in the fishing industry, what we can see is that with risk, with residual risk and adaptation, it's constantly changing. Our priorities and our focus should be constantly changing. So whether that be looking at different types of species available in marine or the Central Arctic Ocean environments, or the fishing industry, or the tourism industry, or transportation industry. All these industries are constantly changing, and with looking at risk, we can't turn a blind eye, because then that's when stuff starts to spiral out of control. So that's what I would definitely want to say about that.
Yeah. So are there any questions from the audience who would like to? Yeah?
Really, really thought-provoking, really interesting, and really appreciated the opportunity to take a deep dive into the Central Arctic Ocean and see some of what we know now. But drawing back a little bit and talking a bit more about what we were the subject we were just talking about. So we have a new global biodiversity framework, and we have a new biodiversity beyond national jurisdiction agreement. Both are calling for 30% protections by 2030. That's not much time. But I've heard a troubling opinion from some folks in government and from Arctic countries that say that likely the Central Arctic Ocean should not be prioritized for a high seas MPA because we have the fisheries agreement, and the timeline for damaging activities is likely pretty long. And I don't think I agree with that, and I'm just would like to get your opinion. Should we be prioritizing Central Arctic Ocean for an MPA by 2030 at the latest? I think we should.
Now, I'm not in governance issues, but my personal quick response would be that we have a long way to go to get 30% protected. I think we should go for every possible pathway we can just go for, and we have many good reasons to also include the Central Arctic Ocean. We've seen how maybe I perceive it as quickly the discussion on mineral exploration has moved in the Nordic seas, and so in terms of precautionary principle, I think we should be on our toes.
Yeah, I could also agree with the Bodil here, and I also mentioned it when my comment previously that I think it's the right way to go actually to protect it, and because I think it will be the Wild West if we don't have the control of what's going on there, and so yeah, because it's a really sensitive ecosystem, and we have to be very careful what we are doing, what changes we are causing.
Yeah, just like the other two speakers, I have to agree with your comments. Definitely one aspect, and I think it's the underlying cause through all of our presentations, is that we know quite a bit about the Arctic Ocean and the Central Arctic Ocean, but there's still that much more that we don't know. So like you were saying before, with the precautionary principle, and we need to take this precautionary approach, especially with this environment. So I think in the future, we should definitely have it as a precautionary, but then reassess it, like I was saying, priorities change, research develops, we need to reassess it and reevaluate it when it's feasible. But yeah, definitely agree with the other two panelists.
I'll add a small comment. I'm not familiar with all the specific wording in the BBNG, but I do know that there is wording that the 30% isn't just any sort of 30%, but that it's specific to particular habitats. And now that that was the point I was trying to make, we have a better understanding of habitat diversity also in the deep ocean. We know that, at least in Norwegian waters, there is a lot of deep oceans. And so now we can be a bit more specific about saying, okay, well, maybe which areas are particularly rich in diversity or in other metrics that we care about in the diversity and in the climate crisis, which are these two big crises we have. And so with that, I think we should not exclude the deep Arctic Ocean.
Maybe I can. Well, I wouldn't agree if someone says because there is a 16-year moratorium, you don't need to put in extra efforts to have this 2030 and 30 by 30 initiative. But I still would go for balancing. Like when we have measures, as I said, I tend to side with, I think that you cannot wait until you know everything, but it still makes sense to balance the scientific information we have, and it becomes a base for our actions. In fact, I would like this to be a motivation and justification for the carefully laid down, carefully designed science projects, big projects.
Thank you very much. And as a scientist, I have to say something too. We have the seabed. There's a lot of new species. we can guarantee that there will come more. We don't even know what we are destroying down there if we start. So the seabed is one thing. Politically, that's also its own thing. It's not easy. So we may say it's under national protection, but it's not clear. Then we have the pelagic zone, we have the ice edge, and as Agnete said, it's shifting. So the ice edge will be moving. So maybe we need to look into moving MPAs. So how do we protect these ice-dependent sea mammals, seabirds, and other ice-dependent species who need to have the last refuge until the ice will be gone completely? Because where do they go? They cannot go up. So do we have a type of an respectful MPA for species who are threatened to extinction? Maybe we should look into that, a kind of extinction rate that can speed up and accelerate processes to happen. And such a moving or pelagic MPA, I think that would be a very nice thing to put into the agreement. Thank you. We have still 5 minutes to, yeah.
I'm still Håkon Harp at Norwegian Polar Institute. The Polar Ocean, or the Arctic Ocean, has some extremely interesting features, which are the big mountain ranges on the seafloor that ranges up, to 1,000, 2,000 meters above the seafloor. And as Bodil showed, the diversity on those ridges, the little that is known, they are quite different from the rest. And as you know, that the deep sea mining is now exploring the mid-Atlantic ridge, and there's been research exploration already to the Gackel Ridge in the Central Arctic Ocean. And potentially they could send down bulldozers and dig up the ecosystems once the ice disappears, because then it's feasible to do at 2,000 meters, 3,000 meters. So there's no protection measures, as far as I know, to protect any of the ridge habitats from such exploration. Fisheries Act is great, or the Fisheries Agreement is great, but there's no other measures for preventing, basically digging up the ecosystem for getting rare minerals. So maybe there should be some plans on especially those areas.
I cannot agree more. I cannot agree more.
Yeah.
Yeah, I agree, Håkon, and still Bodil. And that was part of the motivation, amongst others, for this new synthesis. And I totally agree with you, of course, that we can't stick with, okay, this is what we know, what species live there. But now we can take that and hopefully shape, okay, take it into frameworks of EPSAs or other, or MPAs of criteria of uniqueness and vulnerability and so on to assess and evaluate which areas might be useful to protect or which host the most valued, whether it's in carbon units or in diversity units or other, or ideally even combined, which areas might be suitable for that. But we don't have much time, so I also agree with you. Somebody commented that we can't wait until we know it all, because we're never going to know it all, of course. But we're starting to see patterns even in the deep Arctic or in the deep sea in general. And so those patterns we need to use to make inferences that can be used for these recommendations.
Bodil, you mentioned this EPSA system, and Connor, you mentioned this new system. And as scientists, we have many systems to develop knowledge and facts, and we hand this knowledge over to the politicians, as we did with deep sea mining, and nobody was heard. So it was quite unanimous in Norway that this shouldn't be opened. There shouldn't be any even starting of that process. So what do we scientists do. This is not only case, it could be argued for climate science as well. So what do scientists do when we are not heard? Should we start thinking about how we communicate? Should we be bolder? Should we have opinions? We tend to just hand over the facts, but could we do more?
One thing I've realized very quickly coming into academia is it's not necessarily about every single fact you present, it's about the story, right? It's not how you say it, it's not what you say, it's how you say it, because then that's how we can communicate directly, whether that be to politicians, whether that be to the private sector, whether that be to NGOs. It's really about the language we use, so I feel like it's really about trying to tell and paint a picture story. So maybe in those situations we should try to self-reflect and understand, okay, well, what can we do to further improve that story? How can we critique our story to make it almost like a Disney movie, right? So that's what I would say on that.
Yeah. So formulate our narrative. I think that was also part of the big picture today. So let's do that. Igor, I think we are out of time. So very much to the panelists here for all your contribution.
And also many thanks to you, Liz, for running an excellent panel. A lot of food for thought, a lot of food out there, so let's go for it. So we deserved it, and have a nice day. And thank you for coming.